In this video, we're going to talk about medians and altitudes. So I'm going to introduce both of them, tell you some basic things about the difference of them, and then we're going to figure out ways that we can use them to solve some problems. So the first one is the median in a triangle, and it's a segment that connects the vertex to the midpoint. So vertex to the midpoint. The point of concurrency for the median is called a centroid. And here is what the big thing is in these kind of questions. Is for the midpoint, not for the midpoint, sorry, for the median, if you see the point of concurrency is our point P. So there's this whole length right here, and the distance, if you see the distance from point P to the vertex, so from P to B right here, this longer piece of it, is 2/3 the whole entire length. So what you have to think of is that section right there is divided up 3 different ways. So what I mean by that is if you see my little segment right here, I just read you it a little bit bigger so I can draw some things on it, is BP takes up 2 little pieces. So if you think of dividing it up, that these are technically 3 equal pieces. So there's 3 congruent pieces. So if PF is 5, then we know that the other 2 pieces will also be 5. So then BP itself would end up being 10, and the whole length altogether would be 15. So you have to divide it up and try to divide it up in 3 different pieces, so 3 equal pieces. In the book, if you look at my definition right here, it tells us that it's just the P is the vertex. From the point of concurrency to the vertex is 2/3 the length of that whole entire median. So if you think about it, 10 is 2/3 of 15, but I like to think of it as dividing it up into 3 equal pieces, and that's what I wrote right here. And that might be the easiest way, I think, to think of it is if you have the smaller piece down here, so from the the point of concurrency to the edge of the triangle, so not the vertex way, that if you have this piece, that you can divide it up into 3 equal pieces and then add the different pieces together. All right, so in this one, they tell us that SQ is 8, and that's the part in blue up there. And remember, if you divide this into 3 equal pieces, that's what you want to separate out first. So if I know that SQ itself is 8, then I know that each of the little pieces are going to be 4. So when it's asking me what QW is, I can just look right here and see QW is 4. And SW is the whole length, so that would be 4, 4, and 4, so that would be a 12. So next, if we do the same thing down here with this triangular garden or park, that if SC is 2,100 feet, what I suggest that you do first is redraw out that segment. So this is what it would look like. So if we take 2,100 and we divide it by 3, we get 700. So since each of those would be 700, and then they're asking what PS is, so PS would be 700. And then PC, you can see in here, is going to be 2 of the sections, so that would be 1,400. All right, so I would like you to try the next 2 on your own. So go ahead, push pause, work them out, and then when you're ready to check your answer, push play. All right, so if BT is 1,000 way over here, well, we know these are medians, so it connects midpoint to the vertex. Those should be the same, so TC would be 1,000. And then BC, since that's the whole section all the way across, that would be 2,000. This next one will be similar to what I did before for SC equals 2,100, so you need to draw out the segment and divide it up 3 different ways. Since we see that PT is 800, then we know that AP, since it's divided up into 2 different sections, that they're also 800 each, so that's 1,600 altogether for AP or PA. And then TA, so the whole section would be 800 times 3, so that would be 2,400. For this one again, I would like you to try all 4 of those segments by yourself. When you're ready to check your answers, then go ahead, push play. So this is what your first part should look like. So if you divide up TP and F into 3 equal sections, you get 14 for those 2, so each of the pieces will be 7. So TP will also be 7. So TF altogether will be a 21. So all 3 sections together is 21. So again, if I divide up ds into 3 equal portions, that I can see that each of them are going to be the 8.5 that ps already is. So that means that dp is 8.5 times 2, and that gives me 17. ds is using the same picture, so I can take my 8.3 or 8.5 times 3, and I get 25.5. With PR, I need to use the segment 24 and divide it up 3 ways. Since we see that ER is 24, if I divide that up 3 different ways, I get 8. So when I'm trying to figure out PR, I can see that that is 2 sections right here. So PR is going to equal 16. So we were talking about medians before, and now we're going to talk about altitudes. So altitude is really just another name for the height of a triangle. So it connects the vertex to the opposite side of the triangle, but it needs to be perpendicular to the opposite side. And it could be outside the triangle like it is shown in the second picture over here. When there are 3 altitudes in one triangle, the point of concurrency is called the orthocenter. So almost the circumcenter, but it's the orthocenter. So in this one is just to recognize which type of triangle we have given the different information. So you might want to redraw your triangle that's given over here on the side. We might have to redraw it with each of these so we can mark our markings inside of it. So the first one said that BD is perpendicular to AC. So that's what my picture would look like. I just don't have the letters in there. So because it is perpendicular and it connects the vertex to the opposite side, this would be the altitude. For this next one, it shows that AD is congruent to DC. So it shows that that point D is the midpoint. So the only one that connects the midpoint to the vertex is going to be the median. It's not quite the perpendicular bisector because we don't know that this angle right here is perpendicular. All we know is that it bisects it. So this would be our median. I'd like you to go through now for the last 3, draw out a picture with the given information and decide which type it is. And you could have more than one name that goes with it, just depending on the information that is given. So go ahead, push pause. When you're ready to check your answer, go ahead, push play. So in number 3, this one down below, I can see that my ABD is congruent to angle CBD, and that is just straight angle bisector. The next one with our perpendicular angle down here and the 2 congruent segments, that it is connecting, that this point D is the perpendicular bisector. It can also be the median because it connects the vertex to the opposite side and it is going through the midpoint. It is also the altitude because it is 90 degrees to that opposite side and going through the vertex. So it's 3 different words. This last one is a little tricky because at first glance it looks like it's just perpendicular, but the wrong pieces are congruent. But what you have to realize is that this is an isosceles triangle, that these 2 base angles will also be congruent to each other. And because the 2 base angles are congruent, we know that the 3rd angle will also be congruent to each other. And now we have enough to say that it's the angle bisector. Since we know that there's this side in the center that is the same in both of those 2 triangles. Sorry, there was a little mistake there. That then we know that these 2 triangles will be congruent, so then the 3rd side is also congruent. So then we also have an altitude, we also have a perpendicular bisector, we also have a median. One of the things that you're going to see in some of these altitude questions, just because that is 90 degrees here on both sides, is that we could use that idea to solve for x. So as SUV is equal to 5x minus 10. Then we know that this will be equal to 90 degrees because it has to be perpendicular. So that means we have 5x equals 100 when we add the 10 to both sides. And then when we divide both sides by 5, we end up with x equals 20. So I'd like you to do the same thing now for this very last question and then solve for x. All right, so you're going to have the same setup, so 2x plus 30 equals 90. When you solve for x, you end up with 2x equals 60. And then when you divide everything by 2, you get x equals 30.